Ladies and gentlemen, welcome back from a long hiatus, almost 4 years at this point. So, I used to be with a lot of publications, and SH used to be Sin's Hardware, and now it's Steve's Hardware. So you can go to steveshardware.com. So www.steveshardware.com. And when you go there, you'll be able to sign up for a newsletter, and that's going to be important because I'm going to give this away. I'm going to give away actually most of my samples. I'm not kidding. I'm not like the other reviewers who need to keep my samples and sell them on the black market or on eBay or something like that. I'm going to give them all, well, not all, but almost all away. Of course, no engineering samples. Sometimes I need to keep some stuff. But we're going to do a giveaway almost every video. This first one is a Z490 Aorus Master. Now, this is not the highest grade of GIGABYTE's motherboards. The Extreme, I believe, is $800, and this is around $400. But for $400, you get a lot of stuff. I'm gonna unbox it, look over the accessories, we're gonna open for the first time, we're gonna smell the greatness inside, and then we're gonna go over the components and the features. It'll be fun. All right, so first thing you need to know is that this is a high-end motherboard. This is not something you buy for like a PC in a gaming cafe or something like that. This is a motherboard you buy for high-end gaming motherboard, like PC. So, let's get it done. So we open her up, and she did come with some film on her, and there's a little bit here, and I'll peel that away, very satisfactory later. But you can see it's all metal. This is metal, that's metal, that's metal. Even the audio shield is metal. There is some plastic overlay here, but that's for RGB diffusion. And then copper back and forth. Now this copper actually is important. It's a direct touch to a heat pipe, and the heat pipe is direct touch to the power stages. And that's very important. Plus they use 7.5, I think, MK thermal resistance on the heat pipes, on the thermal pads. So it's very optimized for heat dissipation, which is very important for performance, because the hotter your VRMs get, the less effective the VRMs are. And this motherboard, you don't have to worry about that. I think they over-designed it. Anyways, so you got the stickers here. These stickers, you can put on your passport, on your case, on your laptop, stuff like that. I'm not a fan of stickers. You have a CD here. I don't know why they still give out CDs, but I guess they do here. Manual. This is very important. There's a lot of very important information and a lot of very important things in the manual. Before you buy any motherboard, no matter this board, another board, from any vendor, MSI, GIGABYTE, Asus, whatever, you should read the manual to find out what ports can be used when others are occupied. That's the only thing that will tell you. And also, you kind of want to know where the headers are, everything's located, and that's in here. I know reading the manual is kind of like a mundane and archaic thing to do, but in this case, it's pretty good. Anyways, I don't know what this is. So, we got our case badge here. This is the only thing I put on my case. I wouldn't put those stickers on it, but this is the Aorus case badge. This is your Wi-Fi antenna. So the Wi-Fi on this one is new. It goes up to 2.4 gigabits per second. It's magnetic at the bottom, and it has this stuff on it. So you can unpeel that after you unpeel your board. Anyways, so it can go up and down. So you put it on the back of your case like this, it can stick up. You put it on top of your case, it can stick like that. You can do bi-directional. This is a really unique accessory. This accessory only comes with GIGABYTE motherboards. MSI, Asus, ASRock, none of them have it. This is an audio sensor. It's basically a microphone. It does not record you. It records fan speed, so in decibels, so dB. Now it records the decibels in dB, and then it goes back, and you can use it in lieu of a temperature sensor, which is still included in the package. And you can use them maybe together, and you can control your fans that way. So if your fan's too loud, or they're using too much power or something like that, well, this will tell you how loud they are, because nothing else will. And so this is unique to GIGABYTE, and it's actually a pretty cool feature, and I'll show you exactly what on the motherboard that this plugs in. Oh, not fan header, but there's one more thing in here, is G connector. So when you're plugging in connectors in the motherboard from the case, the front panel connectors, you'll use this. You'll plug the connectors into this, and it's labeled here, like here's your power, here's your reset, here's your HDD, LED, stuff like that. You plug them in here, and then you plug this into the motherboard. And then once you do that, you're set. It's very easy, one big plug instead of 6 little ones. So let's go look at the other side. Whoa. Everyone knows what these are. Sata cables. Sata 6 gigabits per second cables, black. There are 4 of them. 2 of them, 1 in each package, are right angled on one side. The other 2 are straight angled. Well, not angled, just straight. Temperature sensor. So you have 2 of these actually, I think, yeah. So they go into these little connectors in the motherboard that are labeled EC. EC stands for embedded controller. However, these go to a specialized chip on the motherboard. When these connect to that little chip, they basically tell you the temperature, and you can use them to regulate your fans. But you also get real temperature out of stuff. So here's the thing. When your GPU is getting hot, right? It's the second hottest thing other than your CPU and your motherboard. Oh, in your system. When you plug these into the GPU heatsink, these will basically tell you the temperature of the GPU heatsink better than anything else could. And so you can use these to regulate your case fans, something your GPU can't do, and something only your motherboard can do. And GIGABYTE has 2 headers on the board, and they give you 2 of these. So that's pretty cool. All right, and then we have 2 RGB cables. They're extension cables. They are not addressable / digital, which is what GIGABYTE calls them. They're just normal RGB, you know, 4-pin. So you got 2 of them, so if it doesn't reach, you got them. Now, let's take care of the beauty. That's actually really pretty, right? Right, cameraman? So that's the anti-ESD thing. Well, ESD protection. Anyways, this motherboard is not light. Anyways, so the first thing you want to do is take off the plastic. That wasn't that satisfying. Anyways, here's the motherboard. This is a Z490 LGA 1200 socket. So it has more pins than the LGA 1151 or 1151 V2 or whatever the hell they call it anyways. Nowadays, we have a bigger socket for more power. The new CPUs and also the newer generation that's not out yet is supposed to use more power. But also, GIGABYTE has done what it has done in the past with the Aorus brand, which is their gaming brand. And so we have RGB here, here, and whatnot. And on the back, we have beauty. A shield. So this shield has 3 purposes. Number 1, it straightens out the PCB. Number 2, it looks cool. And number 3, it cools down the voltage regulators. Now, we flip it back around, and then we take a look. So right behind the copper heat sinks, we have 2 8-pin power connectors. These each can handle 300 watts. On a normal day, they shouldn't handle more than like 200 watts in a bad situation, but they're capable, depending on the gauge of the power supply wire, to handle up to 300 watts. Now, in terms of normal usage, CPU at stock, if you used both of them, neither would use more than 100 watts. You have a fan header here, 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 here. They're all different. These are your RGB headers. And these headers, this is a 4-pin, like the extensions that were mentioned before. And this is your addressable / digital. GIGABYTE calls them digital, everyone else calls them addressable. There's 1 missing pin in the middle, and that's to, I guess, reduce confusion. You have your postcode, port 80, port right here. So it also has 2 RGB headers at the top and also in this corner. So at the top you got a 4-pin and normal RGB, and then you have a digital / addressable. So it's basically the same thing. I believe it's 5 volts. And then in this corner here, you have your voltage read points. So if you want your real VCore, your VCCSA, stuff like that, and also DRAM voltages like VTT, normal DRAM, VPP, you can find them through here. Then you also have your port 80 here. Now your port 80 will tell you all the codes if something in your system's not working. So if DRAM's up, it'll give you 55 or something else. But This is the best diagnostic tool that exists, and it's on this motherboard, of course, because any motherboard over 300 bucks, I've said before, needs to have a postcode display. Otherwise, don't buy it. Anyways, we have a power button here, 24 here. This here is labeled EC connector, and this connector here, basically, I mean, it's one of the temperature probes go. So one of these goes there. And you can monitor temperature at GPU, anything else. Just plug it in and then place it next to where it needs to go. And then of course you have fan headers here. I'm not sure the amperage, but I believe it's anywhere between 1 and 2 amps. And then you have a USB 3.0 port here, 5 gigabits per second, the big port. And then you have a USB 3.1 here with the Realtek switch for Type-C. You're fine with that. And then here you have your Thunderbolt and GPIO connectors. Here you have your 6 SATA ports. And then down here, you have your connectors to the front panel. And then next to that, you have 3 fan headers. And then above the front panel ports is your clear CMOS, and then another EC sensor. This EC sensor right here basically will capture temperature, just like the one up here next to the 24 pin. And then down here, you have a reset connector. And then this thing right here with the little jumper in it, that's a temperature sensor. Leave the jumper in unless you use it. So that temperature probe I showed you guys earlier, this will plug into there. If you're not using it, leave the jumper in. And then we have a USB 2.0, and then TPM module, and then 2 more RGB connectors just like up here. Then you have a BIOS switch here. You can switch between the BIOSes, the backup and the main with that. And these BIOSes are pretty big. And then you have a backup BIOS, main BIOS, switch to back up from the main to it's a program. You can disable that through these switches manually, because otherwise, when you're overclocking pretty hard, it takes a lot of effort, not effort, but it's a real pain when that is enabled. So you can disable it through hardware-wise. And hardware is always better than software when we're talking about overclocking hardware. This header you don't even know about, it just lights up the LEDs when nothing's in the system. And HD audio, obviously. You have your nice Nichicon audio capacitors here, and then we'll watch we'll see the WIMA capacitors under here. I don't know why they covered them up, but it should be fine. And then here, 3 M.2 slots, and then 16 and so on, just like the last generation. However, Gigabyte did something else, but I have to take off all the hardware to show you. All right, so now we get to the really juicy part of the review. So I like to take apart products. And first of all, we have to take off the back plate here to remove the screws, take off the front stuff, like the heat sinks and the shields and all that. But here's the secret with Gigabyte motherboards. That's not how you do it. The first thing you do, there's 2 screws here, always. I don't know why they don't change this up, but there's a screw here. And then if I was you, I would take a picture of this if this is your motherboard and you want to take it apart, like to install a monoblock or something. So 2 screws come off here, and we're dropping now. There we go. We put these aside. Now we flip. Now we can take these screws off on the back. Now this one is also one of the PHC screws, and this one is not. It just goes in the audio section. We have to take off all these screws, but you can't take off the back plate without taking the 2 screws here and here. These 2 screws are different. These screws secure the integrated I/O shield, because remember we did the accessories and we saw there was no I/O shield, right? Well, it's integrated. So you don't have to forget about it or remember it or anything like that. So when you build a PC, you don't have to take everything apart right after you mess up because you didn't put the I/O shield in. So it's integrated here, which is a nice thing. It's not a bad thing. And this screw is a little different than the others because this is part of the VRM construction. So you see the imprints on here? These are VRM doublers. So this PWM here outputs 7 + 1 phases. The 7 get turned into 14 because of the doublers that are imprinted in here. And the 1 is just direct. Anyways, other than that, this thing is a piece of metal. It's a heatsink. And it makes the board more rigid and keeps everything together. So we're gonna put that there. Now we have to take off everything on the back. So they're like a plethora of screws. Plethora, I don't know. I took the SAT a long time ago. Anyways. So these go into plastic, so they're actually screws. They're not like smooth. And then these have to be taken off with pliers. But we're gonna do it very gently because this is a very expensive motherboard. No, we'll wait until we take them. Oh no, these are for the Wi-Fi. We're not gonna take the Wi-Fi off. Okay, so these are the Vrm screws. So these keep the VRM on and they're extremely important. Never do this without grounding yourself because you're around very sensitive electronics. Now to ground yourself, you have to basically touch a ground, and you know, like when you touch a door when you're rubbing your socks against carpet or wearing wool in the winter and you shock yourself, that's electrostatic discharge, ESD. You don't want to do that on this. I mean, you could, I'd laugh a little bit, but you don't want to. And then PCH, which is a platform controller hub. They have springs because it's a bare piece of silicon. You can take them off in any direction, but when you put them on, there is a protocol to it. Okay, I gotta grab some pliers. So these three here, one of them goes in the VRM, the other one here, and the other one here. These two are screws, and this one is like a gentle screw. So we're just gonna turn it a little bit. The best thing to do is make sure you do not mess with the traces. And you want to get to a point where you can actually use your fingers to unscrew. So it's like a socket wrench or something. There we go. Okay. One down, two to go. Now this is the hardest part of taking apart this motherboard, is taking out these standoffs. And I think maybe it's done on purpose at all. Maybe it's easier to do it this way. So now we've undone the front. Like we undid the back, now the front's coming off. Whee! Anyways. So you have these heat sinks, and these are to cool down your M.2 drives, and they have covers on them. You obviously have to take them off first. And then we have the PCH heatsink, and you might want to be very careful about this. It's not a vertical connection, it's horizontal. So you got to kind of jiggle it and then pull. And then you have the thermal paste that was on there, and then more heat sinks on the other M.2. Oh, you can probably remove the M.2 from there. So this is probably the only plastic part on the motherboard, and other than this shield. And this goes over the audio part. Then you have your integrated I/O shield, which has some connectors in here, and they protrude into the rear I/O shield. And then there's screws on the back, but now we can just pull her off. There we go. Okay, so it's a normal I/O shield. It has the grounding mechanics, the electronics, stuff like that. It's hard to put back on, and that's why I'm doing this for you, so you don't have to do it yourself. So if you want to see what's in your motherboard, you know, I like doing it, so just ask. So here's a plastic shield. I guess a second piece of plastic. And it has LEDs built into it, and it'll light this up. It's actually pretty. Is that a pun? Meh, we'll go with it. Anyways, so here's the most important part. So here we have the direct touch heat pipe, and this is a generation that's a second generation of direct touch heat pipe. So we're gonna take this off. 7.5 MK per watt. I don't know what it is, but it's thermal pads. They're not your normal thermal pads. If you pull them off, they don't stick together, they disintegrate because they're extremely thermally conductive, which is exactly what you want. Anyways, so direct touch. So we're gonna do this. I'm gonna show you what direct touch means. I feel bad doing this. Anyways, so you have copper here, and this copper has been shaved down in the heat pipe to have a direct touch to the thermal pads that directly touch the power stages. And this very much includes increased thermal. I'm just so upset I did this. It's fine. I'll replace it with something else. Anyways, so it's also copper fins. So this is the best way to cool a voltage regulator module or any piece of electronics. You want copper, not aluminum. And you want thinner, more airflow, more turbulence, more surface on surface with air in the metal. So now, the motherboard is nude. So let's talk about the most important part, the voltage regulator system. Now the voltage regulator on here is a 14+1 phase voltage regulator. However, it's not naturally 14 phases. It's naturally 7 phases. Now if you think about phases, each phase fires off at one point in time, but they fire out so fast, they could all fire off at the same time, and you wouldn't know if they fired off right one behind each other because they just fire off so fast. And typically they do fire off one after each other, but you wouldn't know. Anyways, the current that goes through each phase is very important because the voltage that goes through each phase on every motherboard is pretty much the same on every motherboard depending on the voltage you set. The current is very important. They're brand new and they're from Interstilled ISL 99390. And from what I hear, they're rated 90 amps continuous output. Whoa. That's a lot. I wouldn't expect more than like 40 to 50 out of them, but 90 amps, if they actually do that, go Intersil and go Gigabyte. Anyways, so you have a pulse width modular controller here, and it outputs 7+1 PWM phases. The +1 is for a secondary stage. So it's a VCC SA, which is a system agent voltage. But VCC is the main one, and ISL PWM is ISL 69269. And it's a digital PWM, so it means that it uses a PID algorithm to basically check every time it goes around and digitally figure out how to alter the stages. Now here's the beauty of it. They actually use doublers on this motherboard. They're the ISL 6617s. These are current balanced, so they have current on each phase. So what that means is that they actually measure the current and they balance the current between the phases. So it's smart. It's a smart, but it's also rudimentary. So it just goes in and it measures the current and it balances it. It doesn't go through a computer or anything like that. So they're basically mixing a very digital system for control, like a brain, and a very analog system like your body handles, like your muscles, stuff like that. So it's very good. There's 7 of them on the back, so it takes 7 phases and makes them 8. No, it's 18. Anyways, so these and these are all the newest ones. And then this one here, yeah, this one here, that's a VCCSA, actually uses a different inductor. And I believe it's the SIC from Vishay 651A. It's more than enough. Anyways, so that's the voltage regulator, more than enough. And GIGABYTE has mixed tantalum capacitors. So tantalum is a very, very expensive material to use to make capacitors. Now their ESR is a little bit more than the solid capacitors you have here, but the tantalums have other qualities. So mixing them, high frequency, low frequency, everything's filtered out. They do a very good job at it. Now, we go to the back, more tantalums. It's actually one of the marketing points GIGABYTE uses, but most people overlook. So these tantalums on the back are very good, and see, they mix the tantalum with the MLCCs. MLCCs stand for multi-layer ceramic capacitors. Those are these little things that people usually break off their motherboards. So there's a mixture here. So high frequency, low frequency, they filter it all out, which is exactly what you want. So the Masters are one of their top of line motherboards, especially for overclocking. You don't want to over-engineer your motherboard for overclocking. Let's move over. So, oh, nice. Okay, so I just figured something out. So GIGABYTE put in these DIMMs, but these traces on these DIMMs and this standout. So anytime an electronic component comes out of PCB, it picks up noise, electrical noise. And not the noise you and I hear, but a noise that like no one hears. And what happened here is they cut these very short. Now they cut these very short and ensure that none of them come loose. Solder has to go up. Solder quality has to go up, and so does manufacturing quality altogether. So they actually did that. So I like the Dram Dimms here. Okay, so we have a single phase here for the memory, and you might think a single phase is a little bit on the, low side, but I think it's fine here. So this is in a one low side MOSFET and a one high side MOSFET configuration, all the same MOSFETs with an RT8120D controller. And it's kind of standard for most Gigabyte, but power delivery is not a big issue for DDR4. Probably would be less for DDR5, who knows. Anyways, so going down here, we have QC Quick Charge 3.0, and it's a proper hardware port here, and it actually supplies this USB 3.0 internal port. Okay, 5 gigabits per second. Most cases have this, well, almost all cases have this now. And then you also have a USB 3.1 port here, which is 10 gigabits per second. And they call it USB 3.22 or whatever. I don't know. It's 10 gigabits per second. And there is a Realtek switch, actually right here. This Realtek switch helps it actually be a USB Type-C port, so you can actually put it in either way. Otherwise, you can't. Not all USB 3.1 Type-C ports are the same. Not all of them will be reversible. Just saying. People will find that out come the day. Anyways, so we have our Thunderbolt GPIO ports, 6 SATA, whatever. We went over this earlier. Okay, so here's something cool. These BIOS ROMs here and here. They're pretty big, larger than the last ones. These are 256 megabits, okay? That's 32 megabytes. You just divide by 8. You got 2 of them, backup BIOS, main BIOS, switches here control them like I explained earlier. These are very expensive switches, BIOS ROMs. They're not cheap because no one sources them in bulk, like you source like a quick switch for PCIe 3.0. So these are quite expensive, and Gigabyte put them on here. And you know what that means? It means this board is secured for the future. So let's take a look at power delivery. Memory power delivery is here, of course, RT8120D. So we got external power delivery here, voltage read points, and we have the memory here. All the same MOSFETs, not a big deal. I mean, this thing goes really high. And then we have the quick charge hardware here. It's by GL. And then we have the boost converters. So you have buck converters to take 12 volts down here, the voltage regulators, from 12 to like 1.2 volts. Here, but we have boost converters. Boost converters take a lower voltage and pump them up. And this is exactly what these 2 inductors here indicate, as well as the chips before them. They're MOSFETs that do that. Anyways, so this USB 3.0, 5 gigabits per second port, has boost converter, quick charge 3.0 capability. The USB 3.1 here, which is 10 gigabits, is a Type-C. It's a true Type-C. It has a Realtek controller that does it. I think the Realtek controller is RT5441. Now, I guess that's common nowadays because I've seen it all over the place. And we talked about the BIOSes. They're 256 megabits, so they're 32 megabytes of BIOS. And that means expansion for future compatibility with newer processors. That's why they increased the BIOS size, and that's why they spent the money, because usually you buy stuff in bulk. And you can't really buy 256 megabits in bulk because not many motherboards need it. So you don't. But in this case, Gigabyte did. Well, Gigabyte/Aorus. Anyways, we're not even into the good part, because I have a nice surprise in store for you. This is an ITE 8688 controller. Super I/O controls all the fans, all the other random stuff. You also have an IT 8795, right? Yeah, 8795E that controls the RGB. You see these switches here? These are PCIe 4.0 switches. This CPU does not support PCIe 4.0. There are redrivers and there are switches. That's a very expensive hardware for a CPU that's only available now for this socket that doesn't support it. So that means in the future, this motherboard will fully support it. You want to hear something better? There are 2 more on the back. These shouldn't be there. When I asked the engineers, why are they there? They said no comment. So I traced the traces back where they started, and then I traced where they ended. Here's what I found out. There will be support in the future with a CPU that will basically do what Intel competitors do. It will support PCIe 4.0 not only on the slots on the front, right, but also one of the M.2 slots. will be able to handle PCIe 4.0 speeds. So you can go above 3.5 gigabits per second, or 32 megabits per second. But that's kind of cool, right? 32 gigabits. So Gigabyte has put in the hardware in this motherboard to support future processors that not only output 16 lanes of PCIe for the lanes, for the GPUs and like whatever else, like a captured card or whatever, but also the M.2 slot. Now, I did hear internally that they're not allowed to talk about it. I didn't sign that NDA. So this motherboard will support the future of this platform to the furthest extent it can go. And that's impressive because I did look at a lot of boards. I look at a lot of Gigabyte boards, I look at a lot of competitor boards, and there are not many of them to do this. And I did ask a couple Gigabyte guys, and they said, yeah, only a few of our top-end boards support this technology, and the Master is one of them. And so is the Extreme. I don't know about the Elite or the Ultra, and I'm pretty sure it's not on the others, but this motherboard will support PCIe 4.0 if you use the correct CPU. That hasn't been released yet. But of course, we'll get that CPU and we'll test it and we'll tell you how it works. Anyways, we're not done. So here's the audio. ALC 2020. It has a DAC, ESS Sabre, and I believe it's a 9118 EQ. So probably like 125 decibel SNR, which is pretty good. You got your WIMA ceramic capacitors or film capacitors, and then you have your electrolytic audio capacitors from Nikon or Nichicon or Chemicon. This board uses two USB hubs, one here, one there, to expand USB 2.0 times 4. And there's not much on the back. It's a pretty great motherboard, to be honest with you. Very durable, very good, and also it might be yours because I'm gonna give one away. And I'm gonna give it away. There's some things you gotta do. You gotta subscribe, you gotta, you know, all that stuff. But we're gonna give some away, and in the future, we're gonna give away almost all of our samples. Well, 90%, but still more than anyone else. Hey, guys and gals, I loved having you here. If you came all this way and you stayed all this way and you actually listened all this way, I thoroughly appreciate it. Please list any questions or comments you have in the comments. I will respond to them. And steveshardware.com.